Okay, in this video we will be discussing theoretical probability, in particular with example 2. We're going to be looking at further in this example consecutive and simultaneous events. Now consecutive events are events that occur after each other. Just looking at this bag of marbles really quickly, which is what it is. And a consecutive event would be something along the lines of saying, what's the probability of selecting a red ball and then, a red ball and then a blue ball. Okay. Simultaneous events are events that occur simultaneously or at the same time. So an instance of that would be, what would be the probability of selecting two balls, one of which is red and one of which is blue. Okay. In probability, it's more or less we can treat these things as similar. However, there are instances where we need to be a little bit more careful with regards to treating them as the same thing. Okay, and this is one particular example. The first part of this example, I'm going to go through just a quick revision of the probability formula with regards to drawing a specific colour, just one event. So drawing one particular ball out of that bag, just to review the last example. Okay, example 2. A bag contains 6 red marbles, 4 blue marbles and 2 green marbles, and we have that illustrated here. Using the theoretical probability formula, determine the probability of the following. Before I reveal this first question, which as I said is just a single event with regards to a revision from last lesson or from the previous example, we need to note here, assume the balls are replaced back in the bag once they have been drawn. Now what that is suggesting is that with regards to the questions further in the example, when we have multiple events, if we draw a ball out of the bag, let's suggest we were to draw this blue ball out of the bag as a first draw, we must replace it back into the bag before we do our second draw. Okay, so it's important that we note replaced, okay, because if it were not replaced, we would have to treat this problem a little bit differently. Using the theoretical probability formula, determine the probability of the following. Drawing a red marble, and as you can see it's just a single event, the probability of drawing just a red marble. This is, as we said, theoretical probability, so we're going to have to use our theoretical probability formula. P bracket E equals NOFO on NOPO for short, but what it really means, you should say it in your head when you write it, the probability of an event occurring is equal to the number of favourable outcomes divided by the number of possible outcomes. Once we've established our formula and the process for solving this particular question, we substitute into that formula. Okay, and what we're substituting into in particular is our event, which in the question is a red marble. Okay, and the number of favourable outcomes in this question refers to the number of red marbles in the bag. So we go ahead and count 1, 2, 3, 4, 5, 6, or you can read 6 in the question. Thus we have 6 as a numerator. We then need to draw in this vinculum, and our number of possible outcomes refers to the total number of marbles in that bag, which is, if you count all the balls in the bag, you should get 12, or you can add the 6, the 4 and the 2 to get you 12. 6 divided by 12 is, or 6 on 12, we can simplify as a half, because 6 is half of 12. We can express that as a decimal and then as a percentage. Expressing this fraction as a decimal, we simply divide 1 by 2, and expressing this decimal as a percentage, we simply multiply the decimal by 100. That's the first part. I am actually going to flip over the page and skip that quick little example there, and we'll go, let's call this one B. Okay, we'll call this one B. Alrighty. So question B, it's asking us to calculate the probability of drawing a red marble and then a blue marble. Note in the brackets I've also written, assume the first marble was replaced, which is what we spoke about previously in the question. Now this is a consecutive event in the sense that we have a red marble being drawn first and then a blue marble being drawn second. Okay, I've sort of squiggly underline the and then to highlight the importance of those words with regards to consecutive events. Consecutive. Okay? How do we go about this problem? Well, it's more or less the same as what we did in example 1 to start with regards to writing the formula. Note, improbability and then generally refers to consecutive events, meaning we have to multiply both individual probabilities. Okay, so in this instance, we have got an and then. Okay, we have got one of these. So we're going to have to multiply something later on in this problem. But for the first part, we're just going to establish our theoretical probability formula. We're going to substitute into the event, which we can essentially just write from the question. We're looking for the probability of drawing a red marble and then a blue, so you can simply write that in for E, which is what I've done. The probability of a red and then a blue is equal to. Okay, and this is where we have to refer back to this little note just here. Improbability and then generally refers to consecutive events, meaning we have to multiply both individual probabilities. Okay, so we've got multiple events, but with regards to the multiple event is just made up of individual events. Okay, and the first of those to occur is the probability of drawing a red. Okay, in order to satisfy this, in order to draw a red and then a blue, you firstly need to draw a red, and then, which up here we've stated refers to multiply, so I'm going to circle that and draw an arrow to show its importance with regards to multiply. Okay, so the probability of drawing a red and then, and even if you want to do a little multiply above there, just to help you out, a blue. Okay, I've drawn in with an arrow the multiplier representing the consecutive events, okay, the and then. Okay, well, if we just forget about all that gibberish there on the left hand side and just looked at these two individual things, what we essentially have is just two lots of example 1 where we have to multiply the two results together, which we go ahead and do. So the probability of drawing a red is equal to the number of favourable being how many red were in the bag divided by how many balls were in the bag in total, which is simply there were 6 red out of 12 balls in total. We then multiply that result by what is the probability of drawing a blue, assuming that we replace that first ball. If we replace that first ball, there's 12 balls left in the bag, being the number of possible outcomes. Okay, and as a numerator, the number of favourable outcomes for blue was 4, thus 4 divided by 12. We've now got two fractions, which we are simply being asked to multiply together. Now we can do that with a calculator, or you can just do that with pen and paper, however you want. Quickest way would obviously be a calculator. Okay, 6 4s are 24, 12 12s are 144. That there, noting that both of the last digits for the numerator and the denominator are even, you immediately recognise that it's divisible by 2, therefore it can be the fraction can be simplified. So I'm going to simplify that fraction, and in its most simple form is 1 on 6. Okay, all I've done to get that result is I've divided the 24 by 24, and I've divided the 144 by 24 as well. What I do to the top I must do to the bottom. Alternatively, if you have a scientific calculator, the process is made a hell of a lot easier. 1 divided by 6 as the decimal is 0.166666, round one of those 6's up to 7, and multiply by 100 to get our percentage. Okay, so that there is our first example of a consecutive event with regards to this situation here with our bag of marbles. Okay, let's have a look at the next example, and let's not call it D. Let me rub that out so it looks a little bit more even. Let's call that C. Okay, and we're going to look at the probability of drawing a blue marble and then a green marble. Once again, assume first marble was replaced. Alright, I'm going to underline this, and then it's consecutive, and we need to start thinking about and thens as being consecutive events, and then consecutive events refer to multiplication. A little friendly reminder for myself. What we're firstly going to do, just like the last question, it's the exact same style as the last one, so we've got this up here to help us out if we ever get stuck. There's our process, and we can use that for this question. We need to write our formula for theoretical probability. Then we need to substitute. Our substitution for this particular question, the event, or the favourable event, is drawing a blue and then green. Thus, blue and then green. Just a friendly reminder to myself. The more I see it, the more likely I'm going to remember it, and that's a really important thing to take note of. Alright, there's my event, blue and then green. In order to satisfy this, first thing I need to draw is a blue. Okay, so we're going to calculate the probability of drawing a blue, firstly. And then, we know, okay, I need to now multiply, and I'm going to multiply by the probability of drawing a green. Because in order to satisfy this, I need to draw a blue and then multiply a green. Thus that. Substituting into these with regards to our original formula, the probability of a blue is equal to 4 favourable blues divided by 12 marbles in the bag. Okay. How we get our 4 on 12 is from this formula. We then multiply, looking at the line above, the probability of a green. Now the probability of a green is the number of favourable being the number of greens, which is 2, divided by however many balls were in that bag, being the number of possible outcomes, which is 12. Now if we did not replace that marble, initially this would drop to 11. Okay, we need to make sure that we note that up here. If it's replaced, then it will be and remain what it originally was, which was 12. If we multiply those two fractions together, we get 8 on 144. Let me slide this up a touch, hold this down, like so. And we note they're even, numerator and denominator, therefore it can be we can simplify the fraction, We get 1 on 18. If you throw it into a scientific calculator, it's done nice and quickly, or divide the top by 8 and the bottom by 8, you'll get this result. 1 divided by 18 as a decimal is 0.0556, and multiply by 100 to express as a percentage, and we get 5.56%.